Hello and welcome to Chapter 5, Section 10, Transforming Linear Functions. Now we're going to take the linear functions, the lines that we've been studying, and we're going to move them around. So we have to understand a family of functions, and those are the functions whose graphs have basic characteristics in common. Now, we're looking at linear functions, and all linear functions are aligned. So all linear functions are in the same family of functions because they all look like a line, as opposed to something with x squared in it that looks like a parabola, or absolute value of x that looks like a v shape. The parent function is the most basic function in a family, and our parent is going to be the easiest linear line, which is y equals x. This is the most basic function of our linear family. A transformation is a change in position or size of a figure. Now, it's a line that we're drawing, so our lines don't get fatter or skinnier. When we start doing transformations of triangles and rectangles and things like that, then you worry about size. But for this chapter, all we're doing is moving our lines around. We're going to do there's three different kinds of transformations. There's a translation, which is a slide, a rotation, which is a turn, and a reflection, which is just a flip. It's a mirror image. And everything that we're going to be doing is over the y-axis. And that's going to make it easy. And they're doing this because they want us to see the parts of functions that functions have in common. So we're looking at this to get to know them a little bit deeper and on slightly different levels. A translation is when we slide a line. And this is where the slope of the line is the same, but the y-intercept changes. As we slide our line up and down, the slope of it stays the same. So that family of functions looks like this, where starting at 1, we go up 3 and over 1, up 3 and over 1, and we end up with this line. And starting at 3, we end up with this line that is parallel. And starting at 6, we end up with this line. So all we've done is slide this line up 2 or 3 spaces. So this part of the line is the same, and this is the part that changes. That's a slide, a translation. A rotation is where the y-intercept is the same, but the slope changes. So you're drawing a line, and the y-intercept is the same, but the slope of that line is going to change. So notice that it stays in the same spot. It's always going to start at 0, 4, but here we're going to go up 2 and over 1 and draw that line. And here we're going to go up 3 and over 1, and we're going to draw that line. And here we're going to go up 1 and over 2, and we're going to draw that line. And this is called a rotation, and I'm hoping you can see that this is rotating about the spot on the y-axis. So the y-intercept is the same, but the slope changes. The third kind of transformation is a reflection, when the slope is negative and the y-intercept is the same, and that's going to give you a flipped mirror image. For example, we're going to start at our 1, we're going to go up 2 and over 1, and I'm going to draw this line. We're going to start at our 1 again, and we're going to go down 2 and over 1, and I'm going to draw this line. And what I want you to see is I took this line and I flipped it over, and it gave me this line. So it's got a mirror image over this reflection point. Okay? What I'd like you to do is try these three. Try recognizing them. Starting on page 370, please do check it out, numbers 1, 2, and 3, so you can try one of each of these. It's going to ask you to graph it and describe it. Pause here and come back when you're done. So I've done all three of these on the same graph, but in different colors. So for the first one, I graphed y equals x plus 4, and then I moved it 6 units down to y equals x minus 2. So I've graphed both of the lines that they've given me, and I notice that the slope stayed the same. It's just the y-intercept that changed, and it went down 6 units. So I've described the movement. For number 2, the green one, I've graphed the two lines, y equals 1/2 x minus 1 and y equals 3x minus 1. Both rotate around the 0, -1 but the slope has changed. And so by describing this, I've said it rotates around this point on the y-axis. Number 3 is in blue. I've graphed 2/3 x plus 2, and then I made my 2/3 x negative. Negative 2/3 x plus 2 has it stop in the same spot on the y-axis, but now I'm going down 2/3 instead of up 2/3, and this is a mirror image of each other around this axis. The next thing this asks you to do is multiple transformations. Can you recognize what is happening between one equation and the next? So if I ask you to find the transformations from y equals x to y equals 3x plus 1, can you track them? So we're going to start by noticing that I have to multiply the x by 3. When I change the slope like that, that's a straight rotation. So now I've gone from y equals x to y equals 3x. But notice that I'm still at 0.00 as far as my y-intercept goes. So I'm rotating around the origin, 0.00. But I have to get here. So if I'm going to go from y equals 3x to y equals 3x plus 1, all I'm doing is changing the y-intercept by 1. That's sliding it up 1 unit. That's a translation. And that gets me from my starting spot to my ending spot with a rotation and a translation. Hopefully most of these are pretty straightforward for you. I'd like you to try. Check it out, number 4, to make sure this makes sense to you. Pause the video here, have a look at that, and come back when you're done. You do the thinking first, then have me check your work. So with number 4, we started with y equals x, and we went to y equals negative x. And when I change the slope just by making it negative, that's a reflection over the y-axis. Then the next thing we did is we slid it up the y-axis by 2. We just changed the y-intercept. That's a translation up 2 units, and that gets me from our starting point to our ending point. How'd you do? The last thing we have is a business application, and you can follow along on the word problem in your book on page 372. A trophy company charges $175 for a trophy plus 20 cents per letter for the engraving. The total charge for a trophy with X letters is given by the function f of x, or y, equals 0.2x plus 175. This is the trophy, these are the letters. How will the graph change if the trophy's cost is lowered to $172? How will the graph change? So, if we start with a graph that starts at 175 and it goes up 2/10, because that's really 2/10. So that line is going to look like this, starting at 175, and now this stays the same, but we're moving it down to 172. How does that change? Well, all we've done is taken our line and drawn a parallel line starting at point 172. So all that did was sliding it down. We have a translation down 3 units, or $3. Then the next question, how will the graph change if the charge per letter is raised to 50%? Well, this is our slope. So if we go back to our original thing and we change the slope, that's going to mean that we're keeping our y-intercept the same, but we're changing the rotation of our line. Now we're going to go up 5 and over 10, or up 1 and over 2, and now that line looks like closer to that. So if we do this, we are going to rotate about the 0,175 point. So we've answered both of our questions now. You have a similar set of questions on Check It Out number 5 on page 372. Give it a try and come back when you're done. Number 5, what happens if we lower the letter to 0.15x? Well, that's going to change our slope, but not affect our basic rate for the trophy. So that's going to be a rotation that's closer to the horizontal. So in our graph, it's going to go up. This is 15 over 100 now. This is going to be pretty close to horizontal, where the other one had a little bit more of a steepness to it. And then what happens if we raised it to 180? That's a translation up to 180. So we're sliding up the axis from 175 to 180. Okay? Okay. Your homework tonight is page 373, numbers 20 to 45. And once that's done, we're working on the review, which starts on page 382, doing numbers 1 through 62 all. We have a test coming up, and that test we're not going to be able to get to before Christmas break. What I'd like to do is get completely through the review problems so this is strong with you, and then we will spend a couple of days in January reviewing before we end up with the test either starting that Friday or that Monday that we return. So try and get everything finished that you can now, and I will see you tomorrow. Make sure to ask you any questions that you have, please, because we do want to be strong in this stuff, because this is the foundation for all the rest of our graphing for the rest of the school year. So please make sure that you are strong in this. Have a good one.